How much do you really know about turbochargers? Let's start with their history. The turbocharger was first invented and patented in 1905 by a Swiss man named Alfred Büchi, and its first widespread use was with aviation as a way to help planes maintain power at high altitudes where air is thinner. The first successfully turbocharged aircraft was the Lepaire LUSAC-11 in 1918. Some of the other notable first uses was the Lockheed XC-35 and Boeing B-17 Flying Fortress. Now, as for automotive history, turbochargers started to make their way to diesel engines in ships and trains in the 1930s and 40s. And in 1962, the Chevrolet Corvair Monza Spyder hit the market with the first production turbocharger. Also in 1962 was the Oldsmobile Jetfire, the first turbocharged V8. The turbocharger brought you some of today's greatest legends, including the 1975 Porsche 911 Turbo, the 1980 Buick Regal T-Type, and the 1989 Skyline GTR, and of course, many more. So now you know their history, but how do they work? A turbocharger uses the energy from an engine's exhaust gases to spin a turbine. This turbine is connected to a compressor wheel on the other side via a shaft. As the turbine spins, it drives the compressor, which forces more air into the engine's intake. More air means more oxygen, allowing the engine to burn more fuel, creating more power from the same engine displacement. This is called forced induction because it forces air into the engine rather than relying on atmospheric pressure. There are two main turbo designs, fixed vane and variable vane, and the difference is the optimal operating range. A fixed vane turbo is designed to operate at peak efficiency only in a certain window of RPM. This causes what is known as turbo lag. On the other hand, variable vane turbos switch vane position to give maximum performance at any RPM. This design is common on diesels and factory performance cars as it eliminates almost all turbo lag. And that's the 0 to 60 on turbos. Have you ever driven a turbo car?